Creating a forensic image. So in this practical, we'll be creating a forensic image of suspect machine using FTK Imager. Following on from the previous module where we captured the volatile data from our suspect machine, and this time we are going to use FTK to acquire a forensic image. So we are going to do this step by step and explain the process as we go through it. Once the image has been successfully acquired, we are going to verify the image and check our results. So let's get back onto the suspect's machine. So here we are back over on the suspect's machine, and you can see that I have already launched into my FTK Imager once again with my hard disk plugged directly into the machine. I hope you remember that we have so far captured the volatile data in the form of random access memory, that is our RAM. And we have also taken a look at capturing the protected files, that is nothing but the Windows registry files. And hence in this demonstration, what we are going to do next is we are going to capture a live image from this suspect machine. Once again, depending upon your preference, you can either use the file menu or the toolbar or create a disk image. So I'm going to go right ahead and select create disk image, and you can see that straight away the please select source option comes up to me, a pop-up. From the top you can see that I have the option, the default option of selecting a physical drive, the logical drive, and image file and the contents of a folder, or if I have the infrastructure, that is a Fernico device. As we know, FTK Imager is a digital forensic tool used for imaging and analyzing digital devices and media. When it comes to selecting the source of evidence type, FTK Imager gives you plenty of options. Okay, it supports a wide range of source evidence types, including physical drives, logical drives, image files, contents of a folder, and Fernico devices. So here is a brief explanation of each source evidence type. The first is to acquire the actual physical drive. These are physical storage devices like hard drives, solid state drives, SSDs, or USB drives that are directly connected to the computer's motherboard. FTK Imager can acquire an image of the entire physical drive or a specific partition on the drive. So that is nothing but the physical drive. Coming next to that logical drive. So logical drives are logical partitions on a physical drive. These partitions are created by the operating system to organize and manage data. So FTK Imager can acquire an image of the entire logical drive or a specific folder within the drive. Okay. Next, image file. An image file is a bit-by-bit copy of a physical or logical drive or the partition. FTK Imager can create an image file of a source drive and save it to a different location. So the image file can be used for forensic analysis without altering the original data on the source drive. So here you can also acquire from an image, and invariably here this is where you could then use a custom image file to create a second image. So that time we are going to use the image file if we have the image file. Okay. Next, contents of a folder. FTK Imager can also acquire the contents of a folder which includes files and subfolders. This can be useful when only a specific folder or set of files is relevant to the investigation. That time we are using contents of a folder. You may also consider imaging the contents of a folder, and this would be useful in situations where potentially you are just simply conducting a simple low-level triage or assisting further analysis Okay, for example, this only takes the contents of a folder, and this does not include any deleted or unallocated files or the folder. So the last thing is Fernico device. This refers to a device that is specifically designed for forensic purposes, such as a write blocker or a forensic duplicator. So FTK Imager can create forensic images of storage devices connected through a forensic device, such as a Fernico device, which allows you then to automate the process. This is more likely to be used, however, within a lab environment. So overall, FTK Imager is a powerful tool that can be used to extract evidence from a variety of storage devices and file types. So coming up, we are going to have a demonstration where I'm going to take you step by step through all of these relevant points, and we are going to acquire an image from a Windows device that is acting as our suspect machine. So, okay, that's it. I'm going to go ahead and select the physical drive and press next. At this point, I'm given the option of which physical drive I wish to select. Why? Because already the suspect machine have the hard disk, and externally even we have connected the hard disk to capture the image. So that's why it is giving the option, where it will give the option to select the physical drive for which we are going to do the imaging. So from the drop down menu, I'll be able to see if there were multiple physical drives available to me. Obviously it has to be. So in this case, I'm going to select the physical drive C, and remember and take care, ensure that you select the correct drive. Okay. And even I have to take care, of course, to select the correct drive for the imaging process. So once the imaging has been started, and after completion, if we go and check and it is the wrong drive we have selected, then it will create a big mess. So please take care before selecting the drive. Take your time, take extra 5-10 minutes, identify the perfect drive. Okay, do it. So I'm going to go right ahead and select the top drive. Once this is complete, I simply click finish, and it then takes me on to the image creation process. I can see at the top that it gives me the image source, and it identifies the fact that this is going to be the physical drive 0. Okay, so we have selected the right drive. I then need to indicate where the image is going to be placed. So under the image destination, I have to select add. The select image type then gives me the options for the format I wish to correct for my image. Once again, I can see that this is RAW or AW RAW. Okay, then Smart E01 or AFF. So you people may be wondering, the newbies, okay, so what is this RAW, Smart, E01, AFF? So let's understand in detail before proceeding. Okay, so the a raw image, that is DD, it is a bit by bit copy of the original and would not contain any additional metadata from the imaging process. So that is nothing but the raw imaging. Coming to the Smart, it is really now no longer used and is used for older Linux processes. So now we are not using the Smart one. Coming to the E01, the best, the favorite. It is one of the most popular option, as this allow us to also use this across multiple platforms. Why? Because it is the NK, it supports to the NCase also. That's why we call E01 as an NCase file format. Coming to the AFF, that is Advanced Forensic Format. It is an open source which is very similar to the E01 file, and this is an advanced forensic format which will then allow me to use this across multiple platforms like E01. So either the E01 or AFF are the two widely used options. So I'm going to go ahead and select my favorite E01 for this demonstration. So in the evidence item information pane, I have the options of adding such entries such as case number, evidence number, unique description, examiner's name, or any initials, and any additional notes which I wish to add to capture my image to give some identity. So simply I'm going to go ahead and just fill in one of these fields and then press next. So the image destination folder is invariably going to be my one-touch hard disk. So once again, I would then need to browse to this location in order to find it. I have one-touch hard disk and I will create a folder called suspect machine imaging, which I wish to use as my folder for the destination of the image. I'm going to go ahead and select that I then need to give the image a file name. We have created the folder suspect machine imaging. Now I'm going to give a name. So I will call it as suspect machine. Again, you will use your own evidence naming convention depending on what type of investigation you are conducting. You can give the identity for your thing. I then have several options to deal with the image fragment size, which I'm going to leave on the defaults, and also the compression size, which you can see, which ranges from 0 to 9. You can see that the default is the middle at 6, not 0, not 9, it is middle 6, so leave it as in default. I can also use the option to use access data encryption and encrypt the image file through the process. So that's another thing, but we are just giving the password to the imaging file. So whenever we are going to access the image file, we have to put the password. So I'm not going to use this. If you people want, you can use and secure your image file, as this also layers in some extra time to the process. If we select multiple options, so the process will take much time. That's why I'm not going to do the encryption. I'm going to leave this on the default settings for this demonstration. Now that I have finished the process, I can take a look at the other options which are available to me, which are like verify images after they are created, okay, and pre-calculate the progress statistics, and create directory listing of all files in the image after they are created. So I'm going to leave all of this checked. So once the drive has been imaged, it will go through a verification process and compare the hash that will be calculated using MD5 SHA1. Okay. So it will calculate both the algorithms of the hash, that is MD5, message digest 5 and SHA1. I'm now going to start running my capture process. Now that it's up and running, it will give me an estimated time that is remaining for the image to take place. This is where it is now a good time to put the kettle on and go have a cup of tea, as this will not be particularly quick process. It will take time, so let's relax. Let's have something like during the session. So I want to give one point, that is, do you know, on average a terabyte will take about 12 hours to actually image. Okay, but once again, this is dependent upon the compression rates and the amount of data that you are imaging. I'm going to go ahead and pause the recording at this moment in time, and we will come back to this once it is near completion. So once completed, the image verification stage takes place. Once the verification process is finished, it then displays the results of the MD5 and SHA1, which we used in this process. So let me take the snapshots of the completed process and save it for the future use. It also gives you the name and sector count and an indication if there were any bad sectors that were identified throughout. So here comes the bad sectors. They are unmapped. Actually, their addresses is remapped to a good sector. Okay, so to cause the bad sectors, there may be various reasons. The reason which we can consider, it may be because of the disk. Okay, the suspect disk where we are doing the imaging of the suspect device. And sometimes what will happen, that unexpected reasons will also arise, like the connection between the forensic bridge hard disk, that is our hard disk, and the suspect machine. So there may be a bad connection, so we need to check the cables and change the cables and try imaging it once again. If so by doing this, they may be, the problem has to be solved. So you can consider the two scenarios, like if the bad sectors are identical, then you just keep the list of all the bad logs for documentation and continue whatever the forensic work you have planned. But if the bad sectors are changing, okay, then first you try the whole process on completely different computer, just to make sure it is not the reading PC, that's why the fault that is causing the bad sectors. Okay, so if the bad sectors keep moving, then I can suggest take at least 2 to 3 copies or 3 to 4 copies images of the suspect machine. So now, depending on if you want to do attempt recovery of the files, then either you have multiple, like 2 to 3 images you have taken of the suspect machine, then out of that images you have to select the least bad sectors, okay, the least number, and you can use it for the recovery attempt. And of course, keep the bad blocks list as documentation with the chosen image. Okay, closing this then ends the whole process, and I could then close down the creation side of things, which will then leave me with my imager on my destination drive. If we come over and go into Windows Explorer, I am now going over onto my hard disk and into the suspect machine imaging folder, which I created earlier. Okay, so I remember that this was the destination drive which we indicated previously. I can now see all of the partition E01 files that have been created and 2 separate logs, one being in a spreadsheet giving me a database of the partitions and files which were created, and also an overview of the suspect 1 machine, which will then give me the verification results and the details of the image itself. So opening up the text document will then give me an overview of the image which has just been created. Obviously this will be date and time stamped and give me every single piece of detail that is required, including the verification at the bottom. This would then sit alongside my image and once again be part of the chain of custody for this particular device. Once I have completed this process, I now have an image which I can then copy and use further in my forensic investigation. So once we have created our image, we now have several other options to consider. Not least would be whether or not we are actually going to seize the suspect machine or the hard drive. And again, a seizing decision would need to be made by whoever is in charge of the investigation. Under all circumstances, it is important to make sure that you keep the original imager and maintain its integrity. You should never work on the original. Remember, you should never work on the original. You have to make copies for your investigations, and you have to give that to your investigator, or if you are going to do it, can keep it and you can give to your analyst team to work on the forensic images. At all times, of course, you should maintain the chain of custody for both the imager and the evidence drive. You have to maintain the chain of custody, COC. And this is about the forensic imaging of the suspect machine. And coming up in the next clip, we are going to take a look at how to create a custom imager from the image we have just captured from the suspect's machine. Okay, that's it.